rule. So this kind of goes back to the image I was showing you guys yesterday, or not yesterday, or the previous lesson. So we're using this. The empirical rule is telling us that each of these sections has this amount of percent in there. So we're going to be using the 68, 95, 99.7. So what 68 means is 34 plus 34 equals 68. If you add 68 plus 13.5 plus 13.5, that equals 95 right here. And then 99.7 is all the percentage points added inside of here with 0.3% left on the outside. So 0.15 plus 0.15 equals 0.3%. So 99.7% of your population will fall within 3 total standard deviations with some really extreme outliers out here. Okay, so when you have these questions, the first thing you're going to want to do is read the question, obviously. Let's say in a particular zoo are normally distributed. The average lion lives 10 years. The standard deviation is 1.4. Okay, so we're going to draw a little line here, and in the middle will be our average, which is 10. And then using this thing, one deviation up, we'll have 34% of our people in there, our lions. So 10 plus 1.4 gives us 11.4. So that's one deviation up. And you could do like that. And then 2 deviations up is going to be 11.4 plus 1.4, which gives us 12.8. And so we're right here. And then 1.4 more gives us 13.8, 14.2 is 3 deviations up. Same thing going backwards, so 10 minus 1.4 gives us 8.6. And then minus 1.4 more gives us 7.2. And finally 1.4 minus off of that is 6.2, 5.8. Okay, and so we have our rough curve, something like that. Let's look at the question. Use the empirical rule to estimate the probability of a lion living less than 7.2 years. So we have to use this. So 7.2 is negative 2 deviations down. So if we look at negative 2 deviations down, what's the likelihood that it lives less than 7.2? So we have to add this number plus that number. So 2.35 plus 0.15 is 2.5%. And we're checking. Okay, so next question. All right, so we have lizards live 3.1, and the deviation is, so this is going to be 3.1 now, so you can basically just erase these numbers here and put in our new ones. So we get 3.1 in the middle, and then our deviation is 0.6. So it's asking longer than 2.5. So if I do 3.1 minus 0.6, I get 2.5. So it's asking everything that's greater than 2.5. So we have to add this 34 plus 34 plus 13.5 plus 2.35 plus 0.15. So all that together, that's 68%. This is, well, here, I'll use a calculator. That way you guys can see how I do it. Or I was doing my head, but okay, so we have 34 plus 34 plus 13.5 plus 2.35 plus 0.15 gives us 84%. And right. Okay. Question 3. Wait. Oh, there it is. Okay. So zebras in a zoo are normally distributed. The average zebra lives 20.5. The deviation is 3.9. And they want to know what's the likelihood of it living 16.6 and 24.4. Okay. So back to here. We know the middle number is 20.5. If we add 3.9 to that, we get 24.4. And then if we subtract 3.9 from that, we get 16.6. So they only care about what is the likelihood of us living, not living, the zebras living as long as that area. Well, back to our little chart, it's 34% plus 34%, which is 68. And we're right. Okay, last question. Here we go. Seals in a zoo are normally distributed. The average seal lives 13.8 years. The deviation is 3.2. Less than 7.4. So we're only going to have to go left. We don't care about the high numbers yet for this question. So we start off with 13.8 in the middle. And we subtract 3.2. So we're going to get a 10.6. And then 3 more off of that, we get 7.4. And that's the number. Oh, sorry. Forgot to flip over my camera. So 13.8 is here, 10.6. I'm just subtracting because we don't really care about the high numbers. It just says what's the odds of less than 7.4. So we don't really care about anything greater than 7.4. So we have 7.4 here. It's 2 deviations down. So 2 deviations down is 2.35 and 0.15. So it's only 2.5% chance that our seal lives less than 7.4 years. And we're done.